Okay, so by now we know what do we mean by 0 of a polynomial. We know what do we mean by the multiplicity of the 0 and how they can be used in order to sketch the graph. We also know the factor theorem, we also know the remainder theorem. Now we are going to talk about one more theorem and we will apply all this information in factoring polynomial functions. So, the another theorem is called rational zero theorem, and I am writing a very informal statement of rational zero theorem here. According to rational zero theorem, if there is any rational zero of a polynomial, if there is any rational zero of a polynomial, the rational zero should be in the form of factor of the constant term over the factor of the leading coefficient. So, there is a constant term in the polynomial. If the factor of the constant term is divided by the factor of the leading coefficient of the polynomial, that gives us possible rational zero. If there is a rational zero, it should be of that type. Well, let's see what do we mean by this rational zero theorem. This is a very important theorem for whatever is coming next. So, it says make a list of all possible zeros. If we look at this polynomial, the constant term is 4, that does not have a x, that is the constant term, and the leading coefficient means the number that multiplies the highest exponent. So, highest exponent is x to the 4 and the number multiplying is -1. So, the leading coefficient is basically -1. Now, what we have to do is make a list of all factors of 4, or I will write here. So, possible, see we are saying possible, we are not saying it is, it is just a listing possibilities. Possible rational zeros should be, in fact you can take plus minus factors of 4, factor of the constant divided by the factors of -1. So, according to the rational zero theorem, possible rational zeros are factor of the constant divided by the factor of the leading coefficient. So, for this example, factor of 4 divided by factor of -1. So, let us think of all factors of 4. Well, that means factor of 4 is 1 is a factor of 4, 2 is a factor of 4, 4 is a factor of 4. Let us think of all factors of -1. Well, 1 is a factor of -1. In fact, 1 and -1, since we will be taking plus and minus, this is enough, minus will come with the plus and minus. So, that means the list is this. The list of the possible 0 is 1 over 1 is 1, plus 1, minus 1 over 1 is -1, plus 1 and -1, 2 over 1 is 2. So, we have a plus 2 and -2, 4 over 1 is 4. So, we have a plus 4 and -4. What this means is, if this polynomial has any rational 0, it should be one of them, meaning that this polynomial, meaning that 7 cannot be a rational 0 for this polynomial, 7 cannot be a 0 for this polynomial because it is not in the list. Not only 7, 3/4 cannot be a 0 of this polynomial because 3/4 is not in the list. However, 1 can be a 0, can be, I am not saying 1 is, 1 can be a 0, -1 can be a 0, 2 can be a 0, -2 also can be a 0, 4 can be a 0, -4 can be a 0. We will need to identify, these are the candidates for 0, we need to identify which of them are really the 0. Okay, let us look at another question. So, suppose we want to make a list of all rational zeros for this polynomial. So, I will say again possible rational zeros. So, possible rational zeros for this polynomial is, in fact, you can take plus minus and factors of the constant. The constant number here, constant means the term, the quantity that does not have any x in it is, you can ignore the sign by the way. So, factors of 2 and factors of the leading coefficient means the number that multiplies the highest degree is x to the third. So, factors of 15. So, now let us think of factors of 2. Factors of 2, now I will be making the list. Factors of 2, 1, we have to take plus minus 1, factor of 2 is either 1 or 2 itself, there is nothing more. Now, factor of 15, now if I think of factor of 15, okay, the factor of 2 is 1 and 2, it's done. If I think of factor of 15, 1 can be a factor of 15, 2 cannot be a factor of 15. So, 3 can be a factor of 15, 5 is a factor of 15 and 15 itself is a factor of 15. So, what we need to have is, well, let me modify this list little bit. So, 1 plus minus divide by the first factor, still 1 plus minus divide by the second factor, again plus minus 1 divide by the third factor, again plus minus 1 divide by the fourth factor. This is with 1, and with 2 now, putting 2 in the numerator, we will get 2 over 1 plus minus 2 over 3 plus minus 5 over 3, why I am saying 5, 2 over 5, sorry, plus minus 2 over 5 and plus minus 2 over 15. So, this is a huge list. So, if I want to write down the list of all 0 will look, all possible rational 0 will look like this. The first one is 1 and minus 1, the second one is 1/3 and minus 1/3, the third one is 1/5 minus 1/5, fourth one is 1/15 negative 1/15, the fifth one is 2 minus 2, the sixth one is 2/3 negative 2/3 and so on. I am tired of writing the list. So, basically if the given polynomial has any rational 0, it should be one of these, meaning that 20 cannot be a 0 of this polynomial because 20 is not in the list. Even 3 cannot be a 0 of this polynomial because 3 is not in the list. 2 can be, negative 2 can be, 1 can be, negative 1 can be, some fraction like 2/3 and negative 2/3 can also be a 0 of that polynomial. This is called, this is the application of rational 0 theorem. If we apply rational 0 theorem, we will be able to make a list of possible candidates for the 0 of the polynomial. At least something is better than nothing. So, we have a small list of numbers which we can try and identify which one of them are the rational zeros. Well, the rational 0 theorem together with factor theorem, remainder theorem and any other thing we learned till now can be used to find all the zeros of a polynomial function. So, the finding zeros of the polynomial function, in order to find zeros of the polynomial function, the first thing we need to do is, using the rational 0 theorem, make a list of all possible rational zeros. Make a list, no choice. From the list, using synthetic division, use synthetic division and identify the n actual 0. Find out one of them which is the actual 0 by using synthetic division. I will show you how synthetic division can be used to identify which of the possible rational 0 is an actual 0. Now, once we use synthetic division, we know synthetic division will give us a quotient. Once we have the quotient, use the same method for the quotient and keep going, keep going, keep going as long as we don't get a quadratic function in the quotient. Once we get a quadratic quotient, we just simply have to use quadratic formula to find the rest of the zeros. Or we can even factor a quadratic function easily. Either you can factor or use quadratic formula to find it. So these are the steps we need to follow. Let me work on one of the problem here on finding all the zeros of a polynomial. So this is a polynomial and we want to find all the zeros. The first thing, I will make a list of possible rational zeros. So possible rational zeros, these are factors of 6 divided by factor of 1. This is 6, this is 1. So I need to think of all the factors of 6 and all the factors of 1. Factor of 6, 1, 2, 3 and 6 itself. Factor of 1 is only 1, so plus or minus. So this is only 1, so plus or minus 3 divided by 1, plus or minus 6 divided by 1. So basically the list is 1, negative 1, 2, negative 2, 3, negative 3, 6, negative 6. 1, 2, 3, 4, 5, 6, 7, 8. Out of this 8 candidate, we need to identify one which really works. Any of them possibly will work. However, we will have to find the one that really works. So in order to do that, what we can do is start from this one. I will take that one and I will do the synthetic division. 1, this number 1 is taken. In order to do the synthetic division, we will write down the coefficient. X cube is multiplied by 1, there is 2, there is minus 5 and minus 6. Let us do the synthetic division. 1 comes 1, 1 times 1 is 1, 2 and 1 is 3, 3 times 1 is 3, negative 5 and 3 is negative 2, negative 2 and 1 is negative 2, negative 6 and negative 2 is negative 8. Well, this is negative 8, the remainder is negative 8. Remember, if x minus 1 is a factor, if 1 is a 0, then the remainder should be 0, this guy should be 0. Since it is a non-zero number, I can say 1 is not of x minus 1. So looking at this number not being 0, I can say 1 is not a 0 of the polynomial, or another word, x minus 1 is not a factor of the polynomial. The two statements are same. 1 is not a 0 exactly means x minus 1 is not a factor. So one unsuccessful attempt. Let's do the synthetic division by another choice now. The next choice is negative 1. So I will do the synthetic division by negative 1 here. So if I use negative 1 to do the synthetic division, 1, 2, negative 5, negative 6. So synthetic division is done. 1 comes as it is. 1 times negative 1 is negative 1. 2 and negative 1 is 1. 1 times negative 1 is negative 1. Negative 5 and negative 1 is negative 6. Negative 1 times negative 6 is positive 6. 6 and minus 6 is 0. Remainder is 0. We are done. That means this indicates that therefore negative 1 is a 0. This is a 0. Okay. So, we found one of them. Well, we can keep trying the same thing for rest. However, I want to do a little bit differently. We can try for 2, -2, 3, -3, 6 and -6 and see where we get 0, one alternative. I am not going to do that way. I will do this way. See, once we do the synthetic division and we know this quantity is a 0, we have a quotient also here. This thing gives us a quotient. So, let me write down the quotient. Quotient is, see, recall the way we write the quotient. The given polynomial is third degree, x to the third. Quotient should start with x to the square, 1 less than whatever the original polynomial is. So, this starts with x square, the first number goes with x. So, 1 times x square is x square, the next one is plus 1 times x is x and -6. Start with x square, keep in a decreasing order. These numbers are just the coefficient 1 times x square plus 1 times x and -6. Now, this is a quadratic polynomial. You can use quadratic formula to find the rest of the zeros, or you can factor it. I am going to factor it because factoring seems to be simple. So, I can write x plus 3 and x minus 2 as a factors. Since x plus 3 is a factor, I can say therefore, -3 is a 0, and from x plus 3 I am getting -3, from x minus 2, 2 is also a 0. So, that given polynomial has 3 zeros, one of them is -1, another is -3, another is +2. After you get quadratic, you can factor or use quadratic formula. If you do not like that, you have to follow the list. If you follow the list using this synthetic division, I will guarantee when you divide by -3, this remainder will be 0, and when you divide by +2, the remainder will be again 0. And you will not get a 0 remainder if you divide by -2 or 3 or 6 or -6.